Okay, at the end of the last video, I had asked you to try these 3 questions on the sheet that I showed you. Okay, so we're going to do them now together. So the first one says, Ben drops a math textbook from the roof of a school. It passes a window sometime later. The window is 1.4 meters in height, and it takes 0.2 seconds to go by the window. How high above the window is the roof of the building? So there are 2 parts to this question. There's above the window, and the window. Okay, so it says he drops it. So if he drops it, VI must be 0. And if it's falling, A must be 9.81 meters per second squared down. And it says it passes by a window sometime later, and it tells us that the window is 1.4 meters in height. So delta D of the window is 1.4 meters, and it's going down. And it says that it takes 0.2 seconds to go by the window. And of course, the acceleration for this part is also 9.81 meters per second squared down. What is it that connects the 2 parts? So it's falling down this way. So the VF of before the window becomes the VI of the window. Okay? And what is it that we're trying to find? We're trying to find what is the delta D above the window. So where do we start? Well, we only have one unknown in the window part, so we should start there. So window. What equation? Well, we have a delta D, a T, and an A, and we want a VI. So delta D is equal to VI delta T, 1/2 A delta T squared. And we're rearranging for VI, so subtract your 1/2 A delta T squared from both sides and divide by time. You cannot cancel these delta T's out because there's no delta T in the delta D term. So VI equals. Now everything's going down here, so we don't have to call down negative. We can call it positive because there's nothing going up. So 1.4 meters minus 1/2, 9.81 meters per second squared, times 0.2 seconds squared, divided by 0.2 seconds. Carefully punch all this into your calculator. And when you do, you should get 6.019 meters per second. So that's the VI of the window. So it becomes the VF of above the window. Okay? So now we have the VF above the window. We have a VI. We want a delta D. So above, now we would use VF squared is equal to VI squared plus 2A delta D. And the VI goes to 0. And you're solving for delta D, so it's going to be VF squared divided by 2A. So VF is what we just found, 6.019 meters per second, and you're squaring it over 2 times 9.81 meters per second squared. And you will get delta D, which is the height above the window, and it should work out to be 1.8465 meters. Okay? So that is number 6. Number 7. Get my papers lined up so I don't end up marking on different sheets. Number 7 says, Jared throws a ball upward from the ground. After 0.7 seconds, it reaches a window, which is 0.8 meters in height. It takes 1.1 seconds to pass the window. With what velocity was it thrown? So this time, it's going upward. Okay? And so this time, we have a window up here, and we have below the window. And this time, it's going this way. So we don't know the VI with which it's thrown, but it does tell us that it takes 0.7 of a second to reach the window. And of course we know A is 9.81 meters per second squared down. And then it tells us the window is 0.8 meters in height. And that'll be going up. And it says it takes 1.1 seconds to pass the window. And of course, A is still 9.81 meters per second squared down. Now you cannot say VF is 0 here. You can't say that because it doesn't say that it stops as soon as it gets to the top of the window. It keeps going as far as we know, so you cannot assume VF is 0 because we have no clue when it actually stops. Okay? We don't know the VI of this piece, but we know it's equal to the VF of this piece. And the question wants to know with what velocity was it thrown. So where should you start? You should start with the window because that's where you have the one unknown. So for the window, oh, look, it's going to look just like the last one. Delta D is equal to VI delta T, 1/2 A delta T squared, rearrange for VI. So it's going to be delta D minus 1/2 A delta T squared divided by delta T. It's going to look just like the last one, except this time we have ups and downs. And so we have to worry about positive and negative. So calling up positive, then delta D will go in as 0.8 meters minus 1/2, and A will go in as negative 9.81 meters per second squared, 1.1 seconds squared, divided by 1.1 seconds. And when you do this, you get a VI of 6.12277 meters per second, which then becomes the VF of this section. So we have a VF, an A, a delta T, and we want a VI. So I would think you'd want to use A equals VF minus VI over delta T. And you're looking for VI. So multiply by delta T and bring it over. So VF minus A delta T. So VF was this, and this is up. So it's 6.12277 meters per second minus negative 9.81 meters per second squared, and the time for this section was 0.7 of a second. And you will get a VI of 12.9898 meters per second. Works out to be positive because these two negatives become positive. So that means up. Okay, so that's number 7. Number 8. Number 8 says, Mitchell is running 4 meters per second when he sees a crazy physics teacher directly in his path, 6.2 meters in front of him. It takes the student 0.5 seconds to decide he better slow down so that he doesn't hit the crazy physics teacher. He can only slow down at a rate of 2 meters per second squared. Will he run into the teacher? Hopefully you recognize this as a reaction time question. So there's the section of, oh, look, there's a teacher there, and then there's the slowing down section. Okay, so it says initially he is running 4 meters per second. So in his reaction time, that's his VAV. In his slowing down, that's his VI. And it says it takes him 0.5 of a second to decide he should try to slow down. So his time under reaction is 0.5. And when he goes to slow down, he slows down at a rate of negative 2 meters per second squared. And he's going to slow down, hopefully, until he stops. And it wants to know, will he hit the teacher? So you need to find his delta D1 and his delta D2, and then see if added together they are bigger than the 6.2 meters he is away from the person. So delta D over delta T, so delta D1 will be V of delta T. So 4 meters per second times 1/2 a second. Definitely higher order math. Delta D1 is equal to 2 meters. Over here you have a VI, an A, a VF, and you want a delta D, so VF squared equals VI squared plus 2A delta D. Rearrange for delta D. VF squared minus VI squared over 2A, but the VF is 0. So negative 4 meters per second, and you're squaring it, so that'll be 16. And negative 4